Here we're just looking at some different notations. For the first one, we're trying to take the first derivative. We notice that y prime is the same thing as saying f prime of x. We've actually seen that in some previous set of notes, which is the same thing as saying the derivative of the function with respect to x. So that's what this is saying. Now, if you're trying to take the second derivative, we call this y double prime or f double prime of x, which is again to say the same thing as taking the derivative, the second derivative of the function with respect to x. And you could do that with third derivative, fourth, and fifth as well. Now, instead of doing a bunch of tallies for like fourth and fifth, essentially we actually just say that number for that derivative. So this one, for example, would be the fourth derivative of the function with respect to x, which is exactly the same thing as this. But again, all of these are saying essentially you're taking derivative after derivative after derivative. Now, for example 4, when we're trying to compute as many derivatives as possible, we go ahead and first take the first derivative. So f prime of x comes out to be, using that power rule, we're going to take that 4, throw them in front. We have 4 times 3, x raised to the 4 minus 1, minus, again, using the power rule for this, we have 2 times 2, x to the 2 minus 1. And the derivative of this constant will just become 0. So for our first derivative, it just simplifies out to become 12 x to the third minus 4x. Now we can continue on and take the second derivative. Again, the goal is to compute as many derivatives as possible. So then let's go ahead and take the second derivative with respect to x. Using our power rule, we end up with 36x squared minus 4. Now taking the third derivative with respect to x, this will just come out to be 72x. When you try and take the derivative of negative 4 again, that's just a constant, so he drops out. Taking the fourth derivative with respect to x, that comes out to be 72. And again, really you're just using a power rule. And then finally the fifth derivative with respect to x, well, the derivative of this constant just comes out to be 0. And that's pretty much as far as we can go. So again, we've taken as many derivatives as possible from our original function, and it looks like there are 5 of them. But again, though, that is example 4 from our 2.3 number 2 set of notes, and just looking at some of those different notations.